Hello, welcome to today's lesson on section 4.9, which is about graphing and solving quadratic inequalities. So let's begin with our first example. So, pretty simple. I'm going to ask you to graph y is greater than x squared plus 3x minus 4. So here's what we're going to do. Because this is standard form, we'll need to find the x-coordinate first of the vertex, which again is negative b over 2a. So it's negative 3 over 2 times 1. So you get negative 3 halves. Then to find the y-coordinate of the vertex, just plug it in. So it's just the same as before. Negative 3 halves squared plus 3 times negative 3 halves minus 4 be 9 fourths minus 9 halves minus 4, which comes out to being what is that? That's kind of a crazy one. I was trying to do this in my head, but that doesn't probably make sense. So let me find the least common denominator for all these. Negative 25 over 4. So your vertex is negative 3 halves, common negative 25 over 4. So we graph it. Which will be located right here. Make a quick table. Say I plug in negative 1 and negative 2. And I think I would get, let's see, with plug in 1. Let me see here. Negative 9. Negative 6. So essentially we're going to have something like this. And of course, we expect to probably be dashed because we have greater than, not greater than or equal to. Then you shade. And in shading is going to be above. Since its y is greater than. The other thing too is that notice how 0, 0 is part of shaded region, right? If you plug in 0, 0, 0 is greater than 0 squared. This is a way to check your answer. Plus 3 times 0 minus 4, you do get 0 is greater than negative 4. So you know it works. Let's try another example. So number 2. Y is less than or equal to negative x squared plus 4. and y is greater than x squared minus 2x minus 3. And what I probably should have done, I'll probably make this change right now, is use different colors. So let's color code this. Okay, draw a coordinate plane. We'll graph the orange one first, which is y is less than or equal to negative x squared plus 4. Okay, for this one, the vertex, if you work it out, I think by now you guys should know how to do this, will be 0, 4. It's going to open down. If you make a quick table, plug negative 1 and 1, you should get positive 3 for each case, and it's solid. And I believe it crosses the x-axis at negative 2 and 2. So that's the first parabola. If I do the blue one, the second one, which is y is greater than x squared minus 2x minus 3, if you find that vertex, I believe the x value would be 1, and the y value would be negative 4. Oops, wrong place. That's just great. Let's put this back in here. Here we go. And if you put in 0 and 2, you get negative 3, negative 3. And that'll be dashed. Then for the shading, here you want to shade above. But for the other one, we want to shade below because it's less than. So it seems that the shaded region will be in between those two curves. So if I shade with green, that's how we do this one here. So pretty simple, right? Also note that 0, 0 is again in the shaded region. If you plug in 0, 0 into each inequality, you'll see it works both times. 0 is less than or equal to negative 0 squared plus 4. And 0 is greater than 0 squared minus 2 times 0 minus 3. So it works for each case. This is our last example, number 3. Here we want to solve x squared minus 2x is greater than 15. So I would solve like the same way as before. So basically put it in standard form. If you can factor it. X minus 5 plus 3. Now this is where it gets a little tricky. There's a new technique called a sign chart. A sign chart is like a number line. You'll see this a lot in pre-calculus and calculus, so it's good I'm introducing it right now. Here's how a sign chart works. You have 0, and of course you have 1, 2, 3, 4, 5. And what the heck, let's put a 6 there. And of course, -1, -2, -3, -4, -5, -6. Now, what you want to do is first locate the zeros or the roots, which are at 5 and -3. Because if you think about it, when x equals 5 or -3, x minus 5 times x plus 3 will equal 0. But we want greater than 0. So here's what we do. You test values. And what you want to do is test 3 different values. Left, middle, and right. Let's try x equals -4, which is right here. Okay, I didn't want to do that. There we go. Just undo it. We'll also test x equals 0 in the middle and x equals 6. And what I mean by test is plug it back in to this right here. So I test x equals -4. I have -4 minus 5 times -4 plus 3, which is negative times -1. That's 9. That works, because 9 is greater than 0. If I test the middle, 0 minus 5 times 0 plus 3, -5 times 2 is -15. No way, because it's not greater than 0. 6 minus 5 times 6 plus 3. Again, that works. So what it means is that anything less than -3 will work for us. Anything greater than 5 will also work for us. And I don't know why it's still erasing the orange line when I did that, but so that means the answer is going to be x is less than -3 or x is greater than 5. We will explore this in more detail when we meet in class during block number 1, and I'll also show you how you can do this in the graphing calculator as well. So x less than -3, x greater than 5 will be the answer for this problem. So that's called using a sign chart, where you find the zeros, plot them, and then determine whether the left, middle, or right, or sometimes a combination of those two things, will get you the correct answer. Alright, we're all done for today, and I'll see you guys next time in class.